because it allows transmitting additional information like meteorological information using the AIS system. For ATOM services that have meteorological networks, this capability offers the possibility of transmitting data with very low cost of transmission. That, for us, is a problem. We have the obligation of maintaining a network of 24 telemetric water level measuring stations, and at this moment, transmission of water level data and condition of a station is done via cellular phone and via communication satellite, where there are high associated costs. These are the position of the 24 stations. So, weather sensors should be directly connected to AIS transponder, and information should be sent via message 8. That is what, when you are doing a plan, you just put that. But when you try to connect your meteorological data to the AIS transponder, you find a lot of problems. The interface required to connect meteorological instrument to AIS transmission capability differs from provider to provider. For example, some of them requires that you use their sensors. But if you have a network installed, that is not a very easy task. Other providers require that you design the interface to doing that. So if you are thinking in doing that, you have to be very prudent. And other operational problems that we have, that we can find, for example, and some of them look like stupid problems, but at the end of the story means that your AIS instrument transponder is not working. For example, there are some equipments that come without the antenna. So you just attach to this transponder a maritime antenna, and you are going to have a lot of problems because of the special frequencies the AIS is using. You should attach a special antenna that have low stationary wave relationship for not losing radiation power. In the paper you see which one we have selected at the moment. But to find this problem, well, we have done a lot of way in the run. Problem with the AIS equipment. You should be very careful at the moment of giving energy to the equipment, because it can be burned, for example, if you are connected in without attaching the antenna. And in some cases, you'd be very careful, because some of these equipment do not accept inverse polarity. What I'm trying to say is that you, in your trying to put this equipment and functioning, you very well, you have to do a lot of investigation. For example, in installation problems, I can mention the water tightness of the box, and with the impact of ships on ATOM that have AIS, most probably, if a ship impacts one of these ATOM navigation, your AIS is lost. You have to have a specialized personnel that usually you do not have at your ATOM navigation service, both at the laboratory and at the field. And usual linternist is not capable of attending one of these equipment. The IALA 2008 questionnaire shows that 99 AIS AIS units were installed in the whole world. So most probably, by hearing my colleagues in this conference, the results from the 2009 questionnaire will show a different picture. So I ask you, please, to fill the questionnaire, so it can help us to know what is happening around the world. Our proposal in this moment is to have a strong collaboration between the different services of A2 navigation, because the experience of one of us can help the other to do their job. And for doing that, we are doing some training courses in Argentina. We have done this with the collaboration of Automatic Power, and we have had people from 5 different countries. So you are welcome anytime at our company. And as example of using data, I will pass very quickly because I see the red light shining. We have additional obligations in our contract, not only to maintain the dredging and the A2 navigation. So, for example, I can show you 2 places where port impact has been done, and I can show you here the position of the impact and the bank effect. I can explain you why this was happening, but every 2 or 3 years a ship is impacting on a distillery there with a very high risk for all the population around that. And on buoys and beacons, ships collide buoys, and we have to detect the ship that collide buoy to recover the cost. Here you see a damaged spar, and here you can see a beacon that was hit, but that ship was charged with the cost of this impact. And we have to improve the design of our channel because it is relatively narrow, and we recover the cost of dredging and A2 navigation through toll of passing ships. So we have to keep it well, but as cheap as possible. And the actual procedure to know how ships are using the channel is very difficult, but with AIS use on data, we can know the real tracks of the ships. So here is the lateral distribution of the ships at the position where these ships were impacting the berth. So that is in a curved channel, this is in a straight channel, and these are the data. We can know also the real speed of the ships following in different parts, and we can find that some of these ships are having velocities much higher than allowed in the navigation, and that influences the squat of the ships and a lot of aspects that is important for us. And I'm ending in a minute. With this part is very important. We have to design a passing section, a passing area, and to now we have the standards to design that. The Piank standard, for example. And we now have the actual data of ships crossing that area, and we can do the design using the real distances between ships and the real use of the channel. ATON monitoring is one of the aspects, detection of passing ships to charge the toll, and we have checked with captains and pilots how they find the use of this AIS on ATON, and we have a